Abrasive wear is one of the main problems in industrial. Abrasive wear can be separated into two types. One is two-body abrasion, another one is three-body abrasion. Two-body abrasion is the surfaces that slide across each other where the hardened material will remove the softer material. The wear particles will produce between the two bodies. For the three-body abrasion, the abrasive particles is placed between the two bodies. The wear rate of the three-body abrasion will be lower than the two-body abrasion due to the abrasive grains in the three-body situation are free to move. One of the two-body abrasive wear in machining industrial parts is abrasive wear at extruders. The wear usually occurs at the high-pressure areas. The wear is caused by the metal-to-metal contact between the flags and barrels due to the screw flexion under these high pressures. It will reduce the fatigue life of screw. This picture shows the condition of screw after the abrasive wear.
There are many ways to reduce the abrasive wear such as material selection, coating, and lubrication. However, some changes of the solutions in machining industrial parts that need to be tackled. For example, polymers are widely used in material selection. The challenge of using polymer has a low thermal resistance and thermal conductivity, which means that it is not suitable to be used in high temperature area. Polymers also not compatible with lubricants as it swells in contact with lubricants, water, and other liquids. Besides, some coatings like using diamond-like carbon or DLC as coating material. The challenge of using DLC is it is too brittle, poor adhesion, and high internal stress, which is up to 10 gigapascal or more. Solid lubricants like graphite and molybdenum disulfide are normally used in machining industrial parts. However, they do not have self-healing properties and it will affect the wear rates.
How do we optimization the abrasive wear in industrial machine part? There are two aspects need to be considered, which are design parameter and operating condition. For design parameter, we first have to concern the material property like hardness. Increased hardness in industrial machine part makes chip removing more difficult, therefore wear rate decrease. Second, surface coating also considered in design parameter. There are two examples of surface coating, which is PVD and CVD. From the figure shows that the machine part with our coating more wear compared to the machine part coating with PVD and CVD. For operational condition, three conditions have been considered. Firstly is the speed. Feed rate is a kind of speed parameter and high value increase coefficient friction which accelerate the wear rate. Secondly is the temperature. Due to the contact condition, heat accumulate on the machine part deteriorate the material's structure which produce stress. We can see that from the figure, the machine part operate at 50 degrees Celsius less wear than at 70 degrees Celsius. Lastly, the abrasive wear also influenced by the load. The wear rate increase as the load increase. This is due to the particle press harder against the surface result rolling and rubbing at the particle on the surface.
Alright, moving on to the last part of this video. My name is Pierre Chow Fan Cheng and we'll be presenting the part regarding the recommendations on the abrasive wear in industrialized machining parts. Based on research, the abrasive wear alone has been estimated to cause 1 to 4% of the gross national product of industrialized nations. And thus, the recommendations that I will be elaborating in this session is about thermal spray technology. Thermal spraying is like a coating process by spraying molten or semi-molten droplets to form a layer of coating, just like what I've been showing right here. And surface covering improves the life of segment and lessens the expense of substitution. And the pictures here are showing the application of thermal spraying in various manufacturing of products, like this, and this. By utilizing the thermal spray coating method, uniform covering thickness, non-stop layer of covering, and high hardness can be acquired, and thus is a more significant strategy of surface change. And that's all from me. Thank you.